All right, guys. Welcome to EE220 Circuits 1. My name's James Kelly. I'm your instructor for this course. I'm going to record all my lectures. As you can see on the left, it's recording right now. And I'm going to post them to the webpage. So if you guys happen to miss a lecture, COVID's still going on, and I know people get sick and we've got stuff going on. Everything will be recorded and posted to the webpage. So if you miss, you're not really missing much. I'm going to go over the course webpage today. I'm going to go over homework guidelines. I'm going to go over some of the software that we're going to use in this class. And then if there's still time, I'll start lecturing a little bit on the very, very basics. So first, let's take a look at the webpage. I don't know how many of you guys, I'm hoping everybody got my email that I sent about the course webpage. This is what it looks like. If not, I'll give you guys, this is going to be on the webpage, and I'll send out that link again if anybody needs it. Basically, this is an introductory circuits course, so I'm going to teach you guys about, the basics of electricity, voltage, current, resistance. Maybe some of you guys have heard of some of that stuff before in physics or other classes. Today, I just want to kind of go over how the class is going to run. Basically, we're going to be integrating, in-person lectures with at-home homeworks, and you guys are going to turn those in. And then I'll give little 5-point quizzes at the end of class just to keep everybody kind of engaged because, I don't know how many of you guys have taken Dr. Baker for courses, but I kind of learned, how to, conduct a course from him. And I've found that even though the quizzes and homeworks can be annoying, it's definitely the best way to stay engaged with the course. And, those weekends when you really just don't want to do anything, you have a quiz Monday, it might prompt you to just look at something. Like I said, the quizzes aren't going to be difficult. They're just going to be little 5-point quizzes. But anyway, let's just go through the webpage a little bit and see what I've put on here. So first and foremost, this lecture notes and videos, this is where lectures are going to be posted. I've got the whole semester dates worth of classes on here already, with the exception of the links. So today is January 19th. It's Wednesday. And after I finish lecture today and upload the lecture, the PDF of the notes will be right here listed, and this will be a link. And then the video file will be linked to the video for that date, and that's going to be the whole semester. So whatever day you miss, there will be a little bit of a description of what's going on that day, and then a link to the notes and the video. It's also not just for if you miss, it's also because I've found, and many of us have found, that it's helpful to be able to go back and if you are working on a homework assignment and you're like, oh, I remember he talked about this in class, but I don't remember exactly what he said. The main point of this is so that you don't have to sit here and try and write down everything I'm saying and everything I'm writing. You can just go and look at it and, spend the time in here kind of actually paying attention to what's going on and trying to process what I'm saying and what I'm going over. So yeah, that's the lectures link. We've got the midterm and the final exam. I don't know why I wrote May 11th. I think I might have just assumed that was the date. If any of you could go on your MyUNLV and notify me when the exam is, I can't because I'm not a student, so I can't actually check for some reason. But if someone can let me know the actual exam time, it should be listed on your MyUNLV. Just let me know and I'll update that. I plan to go somewhat slowly through this course rather than, just flying through it. And I'm going to have, sprinkled review days throughout the class. So, like, for example, there's a review here. I'm going to be doing several days where I just for the last 3 weeks, we've covered this, this, and this. Today, we're just going to review everything and you guys can ask questions. I'm going to solve a lot of example problems because I think that, learning by example is important. So yeah, that's the first link on the webpage is the lecture notes and videos. That's there. Homework assignments will be listed on the homework link with the due date and a link to the assignment. So this is going to be the first assignment. It looks kind of scary, but I assure you it's not. For for those of you who haven't seen this stuff before, might go into a little bit this today, if not definitely Monday. But yeah, it kind of just says the due date up top, and then there's some problems, and you know, I'm gonna list them here. The first one's not due till next Wednesday, so a week from today. For those of you who might miss class, some people emailed me today and told me they're not going to make it. This is where the homeworks are listed, and you just have to turn it in to me via email if you miss class by the day that it's due before class starts. So if you're going to miss, next Wednesday for whatever purpose, just send it to me by Wednesday at 2:30, and there'll be no problems. Like I have no problem grading that. I don't. If you guys have personal stuff going on or whatever happens, you can miss class. I understand, people have lives and things happen. So I'm not like crazy about you have to turn it in person or anything like that. If you get it into my inbox before 2:30, that's all I really care about. Current grades, there's nothing there yet, but this is where the grade sheet will be posted. That's why I have you guys writing on these pieces of paper. So any of you guys who came in, very late, I said this earlier, the little white pieces of paper, just write your name and your NC number on there. I'm going to collect all of those, and I'm going to use your NC number to kind of identify you on the spreadsheet so that people don't know your grade, your name, and your grade based on the name. I'll probably just use the last 4 digits or something that, they don't have your whole NC number, but something that you can identify yourself by. So aside from those 3 essentials, those are obviously the essentials. You're probably going to click on those a lot. I'll skip over LTspice for now and talk about that a little bit later. As far as course information goes, did everybody see that this textbook is free to download? Like nobody paid for it, right? Did anybody pay for it? Okay, good. I'm not going to use it probably at all. But if you have questions from the textbook, like feel free to bring it to me and ask because I'll answer them. But I don't really like the organization of it. So I'm just not going to use it. If you do want it, this link takes you to where you can download it for free. If you haven't downloaded it, it's this book right here. You just hit free download. It downloads as a PDF. This link was provided by the university, so it's totally safe. And if it's not, you can sue them, not me. So that's fine. But yeah, if you want it, it's here. I also have the PDF. If anybody needs me to send it to them, I downloaded it already and didn't have any problems. So today's the first day of the course. Obviously, it goes through Wednesday, May 4th. That's going to be the last, review day before the final, because that's study week, and then finals week is the following week. We're in SDB 1243 right now. You guys had Monday off. We have President's Day off in February. As I said earlier, I haven't gotten to the final exam time yet, so if anybody just let me know what that is, that'd be great. Course content, that probably isn't going to mean a whole lot to you right now. Everybody should have taken Calculus 2 by now. So grading's important, obviously. Only 2 exams. We have a midterm and a final. And then quizzes, homeworks, midterms, and final are all worth 25% of your grade. So at the beginning of the semester, when you finish homework 1 and quiz 1, those 2 things are going to be your entire grade. And, your grade might look really bad if you do bad on the first quiz or the first homework. But I assure you there will be enough quizzes and homeworks to even it out. I don't want to give you pain, but I do know that you have to learn by repetition. So I will probably give more homework than you're used to. It's not anything crazy. It's like if you watch the lectures, it's not something that's gonna waste your time. And I'm not gonna try and trick people. Like it's gonna be straight from the lectures. You're not gonna, have to look on Chegg. It's all gonna be right there in the videos. So don't worry about it. And if for whatever reason I assign a homework that there was something that you're like, dude, he never covered this. Like just tell me, and I'll self-analyze and make sure that I did or didn't cover it, and then I'm very reasonable. So like if I assign something and you guys don't know how to do it, it's because I know how to do it and I forgot to teach it. So just like let me know and we'll nix that homework. Open communication. I don't have any problems with that. So as far as zoom out a little. Wow, okay. I guess do I have like a side scroll? Well, whatever. Course policy. So This first one, no laptops, tablets, or smartphones used during lectures, quizzes, or exams. Mainly that's to keep people focused. Obviously I have a laptop, everyone has a laptop, but using them during class, isn't conducive. I don't think unless you have a tablet like out, flat and you're taking notes on it, because I know that's like a new thing people do. But I would prefer that you don't have your laptop open, because in my experience, people who have their laptop open are probably not paying much attention to what's going on while I'm lecturing. I sent out a Google group link to everybody in here that was on the roster. How many of you guys joined the Google group? Okay, that's pretty good. I think there's 48 people enrolled, and I saw that there was 30 members in the group already, so that's pretty good. I put an invite in my own inbox earlier, so you guys can see what it looks like. So this is what the invite should look like. It should say invitation to join EE220 Spring 2022. So if you want to go ahead and search that in your UNLV inbox, it should be there. If for whatever reason it's not, email me and let me know, and I'll send you an invite at whatever email, It should be there, though, because I sent it to everyone who's on the roster. So check before you email me, please.
Is it possible to put the group link in like the course webpage?
This is the first time I've ever used a Google group, and I spent like 3 hours today looking for how to send a link, and I couldn't figure it out.
Okay.
So if I figure it out, I'm happy to do that. Otherwise, this was the only way I could figure it out. So I'm sure there's a way. If any of you guys know how to send a link, I'll post it on the webpage. I have no problem doing that. I just couldn't figure it out. So let's see, where was I? All right, so yeah, so that group is basically going to be for questions regarding the lecture, regarding the homeworks. So if you have questions, I don't have problems with receiving emails from people. I do have a problem with receiving 6 emails about the same thing, because then, I could have just responded to one person and everyone could have seen my response. So that's what the Google group is for. It's for questions related to the homework or the lectures. Like, feel free to, just load up that group with stuff, because it's going to be helpful for everybody. And I will be in there in that group responding to things. I just won't respond if you email me personally regarding class or homework, because I could have responded in the group and other people could have seen it. So don't email me unless it's, so I said, if there's some personal inquiry or matter you need to discuss, you're not going to make it to class or something's going on, obviously email me. Like, I want to know, and we can communicate like that. But if it's about homework or lectures, please send it in the group so everyone sees my response and your question. I won't accept late work other than quizzes. So this is the thing. Since the lectures are posted and the homeworks are posted, there's no reason why you shouldn't be able to get it to me before it's due, even if it's via email. But quizzes are done in class. So the thing with the quizzes is I want to keep like a quiz-like environment for people who weren't here to take the quizzes. So just when you don't make it to class, just make sure to come by my office hours, and I will give you the quiz in my office. Like, you can prepare and do whatever you need to do. I just want to keep it like a quiz, because I don't want it to be unfair for the people who were here that took it as a quiz, and then you get to, unlimited time or anything like that. Like, that's not, I just want to keep it fair for everybody. So if you miss a quiz, come to my office. I don't care how late it is. If you miss quiz 3 and you're quarantining for 2 weeks, and you come to my office 2 weeks later and take quiz 3, it's going to show up as a 0 on the grade sheet for a minute, but as soon as you take it, full points. Like, I'm not going to dock you for being late on it. So don't worry about that. As if you see a 0 and you missed it, you can still make it up in my office. That's about it for that. Please don't cheat, guys. I really dislike cheating. I know how hard it is. Undergrad is really tough. Like, I just graduated in 2020 from UNLV, and I think that undergrad is really difficult. I know you have like a bunch of stuff on your plate. I'm sure many of you guys are taking 4 or 5, some people maybe even 6 classes. But just don't cheat, because it's not helpful for you. Like, if you're gonna do bad on a homework, just take the bad grade. It's not that big of a deal. They'll even out eventually. And cheating is just, it doesn't help you on the quizzes. It doesn't help you for the exam. So just try and avoid it. I know some people probably will anyways, but I just have to say don't cheat, because I really dislike it. Working together is definitely encouraged on your homeworks. I want you guys to work together because I think it's really good to get in a group, and somebody that knows one thing might not know another thing, and it's very beneficial to work in a group like that. But I have had students turn in identical copies of the same assignment. Definitely don't do that. This guy's laughing because he knows. But yeah, so basically, just if you're going to work in a group, make sure you're just doing your own work. Like, you guys can all work together. You can have the same answer. You're going to have the same answer if you did it right. But definitely don't take 3 or 4 copies of the same assignment and turn it in, because I'm grading everything and I will definitely notice. Calculators are definitely allowed. Definitely get yourself a good calculator. I have a TI-84. It works great. I would prefer that you don't have some crazy TI Inspire that can, take PDFs and you can load a bunch of notes into them, because that's not very honest. But, TI-84, a 4-function calculator. We're not doing anything crazy in here, guys. It's just algebra. So you really don't need more than a 4-function calculator with parentheses to do pretty much everything that we're going to do in this class. The main part is, the engineering and the circuits. It's not the math that's going to be the struggle. Here, can everybody do something for me real quick? I just want to take a survey. Can you all close your eyes, and I want people to raise their hand if you would be interested in me holding a math or algebra review session covering the algebra that's going to be necessary in this class without any of the engineering topics. Just raise your hand. Okay, cool. All right, you guys can open your eyes. I just wanted to see if there was interest. There seemed like there was enough interest that I would do it. So that might not be on a class day. I might do a weekend thing or a nighttime thing one day and just email and see who's interested. Because I know for a fact that the math can trip a lot of people up, because, you come from high school, you come from horrible math classes on this campus, and then you're expected to yeah, you guys know. I don't want to name any professors by name, but I'm sure you guys have had some nightmares. Anyway, I know that, the point of engineering is you're supposed to come in here with Calc 2 background, because by then you've theoretically mastered what you needed to do in this class, which is algebra, right? But I know for a fact people haven't mastered algebra to the level that they need to only focus on the engineering concepts. So I would like that to be the level that everybody's at. The algebra isn't even a problem for you. It's just, okay, let me see how I can solve this circuit. You shouldn't be man, I don't know how to solve for X. That should not be an issue. So I will hold a review session, because it seemed like there was enough people. And I'll just, I'm going to cover algebra. It might seem super basic, but just to make sure everybody, is on the same page with that, I think that would be productive. Make sure you bring an actual calculator for quizzes. They're allowed on quizzes and exams, in class. Make sure you bring an actual calculator, because if you don't have an actual calculator and you're trying to use your smartphone, I will not allow that. I usually carry a couple extra calculators, so maybe I'll grab a couple just in case somebody forgets one, but just try and remember your calculator. So how many of you guys have taken a course from Dr. Baker? Okay, pretty, maybe an eighth of you guys. So Dr. Baker taught EE220 several times here at UNLV long before I was even here. These are all the links to his course web pages, and he records his lectures and posts his homeworks and posts his quizzes. And I'm running my class very similar to the way he runs his class. So this is a ridiculous amount of resources for you guys. For example, my first homework is not going to look very different from his first homework. I mean, I'm making my own homeworks, but for example, this is you guys' first homework. If I go back to the web page and click on Dr. Baker, I don't know, let's say spring 17, because that's when I took it. You go to homework assignments, and then you go to homework 1, and his looks wildly similar to mine. It's slightly different, but this is also a good resource for studying if you want extra practice problems that I haven't posted. They're all here, 7 semesters worth of problems. His quizzes are here somewhere. I think if you click on his lectures, yeah, so he's got his quizzes too. My quizzes are going to be similar to his quizzes, so feel free to solve these, practice them, ask me if you got them right. When we do review days, feel free to ask me to solve some of these. I have no problem doing any of that. Definitely use this. And then he has all his, PDF notes and everything posted, also on here, as well as the video. You guys are starting to see really like a crazy similarity between my webpage and his webpage because I learned everything I know from him. So use these, let's say I go over Ohm's law today or on Monday, and you guys just hate the way I explained it. Go to his and watch it and see if you like the way he explains it better, and then maybe you'll understand. It's good to get information from several sources. YouTube is a great resource. I used YouTube to learn so many things during undergrad and graduate school. I would definitely recommend using YouTube. All right, let's go back and see what else. Okay, so I haven't covered LTspice yet. So LTspice is software. That's where all these, the circuits that you keep seeing here, that's where these circuits were made. Some of you guys have used LTspice before. How many of you guys have used LTspice before? All right, that's pretty good. LTspice is free. It's available on Windows and Mac, so as long as you don't have some like Linux laptop, you should be fine. I have a Windows and a Mac, and I'll start bringing my Mac too for those of you. Does anybody have a Mac? Just one person? I was you, so don't worry. Yeah, I'm going to bring my Mac, so if you have questions about anything with the Mac version, we'll work through them together. It's not that much different, but they tend to update the Windows one more, and so it's like got all the most recent updates and whatnot. What's up? Yeah, it is. I downloaded it. This laptop's Windows 11 and it runs fine. So yeah, if you guys have Windows, I think it's like Windows 8 and up, or Windows 7, 8, 10, and then it also works on 11. So as long as you have like access to some kind of computer, you should be fine. But we will be using LTspice on pretty much everything because it's very important to get a feel for not only like me doing math and writing down circuits and drawing them, but also you building them, understanding how they work, how things are connected. So that's kind of what LTspice is for. What LTspice is it's a simulation software that allows you to build and simulate circuits. So anything I draw in here and we cover, I'm going to say, the voltage here is this, the current here is this, and you can go build that circuit in LTspice and verify that what you did by hand is correct because LTspice is programmed to solve these circuits, So on the homework, you'll notice that I say verify your work using LTspice. What that means is you're going to solve this circuit by hand and you're going to say, VA is 9 volts. And then that's great, but just to make sure that you're right, I want you to take this circuit, build it in LTspice, and then simulate it and make sure that that's right. And then you're going to have your work by hand with your LTspice simulation on the same page showing like I did this and I verified that it's correct. So that's kind of how the class is going to work. I'm going to teach you guys everything you need to know about how to use LTspice. I don't expect you to learn it on your own. However, there are resources here. Dr. Baker's LTspice tutorials are really good. So he has a tutorial on how to install LTspice. This could be like a decade old. So I don't know if it's a great tutorial, but I wanted to link to it anyway. LTspice hasn't changed all that much. So like the keybinds and stuff are all the same. I'm gonna start using it today just so you guys can see what it looks like and start to get a feel for it. But it's a really user-friendly software. It's really easy to use, really easy to download, and it's free. So we use it for pretty much everything. I actually have a friend who just graduated with his PhD. He works in Arizona at an integrated circuit design company. They use LTspice for everything. Like it's a really good software to know how to use. Anytime you want to build a circuit, you can just simulate it in there. Be like, is this going to work? And it'll show you, waveforms, voltages. You can do all kinds of stuff. So we'll go through that a little bit more later. I don't know how the 220 discussion works. Are any of you guys have to show up in person for the discussion, or is it online? Okay, so this is probably the page that you guys have for the discussion, and it's just Dr. Baker's tutorials. So these are here. I linked them here too. We used to have to go in person to the discussion, and that was horrible, so be thankful that you don't have to. And then here's a little bit more on LTspice from Dr. Baker. He's got, kind of a description of how it works, some pictures. His tutorials are linked here too. So just all kinds of resources. You may or may not need these because I'm going to go over all this stuff anyway. That's not your only resource. I'm going to be a huge resource, but this is all supplemental stuff. Let's take a look at the download. So when you click on that link, the download LTspice for free, it's gonna take us to this web page, and you see download LTspice right here. So there's downloads for Windows 7, 8, 10, 32-bit, 64-bit. So whichever one of these you want to use for your computer. And then this is for Mac. So the Mac version does work. Like I said, like don't worry, it's gonna work. It's just different. So there's different keybinds. It looks a little like slightly different, and you'll see. If you have problems, just let me know. I'll show you how to do the stuff via Mac. I might even make some Mac tutorials just for future people so that we don't have to deal with any issues. I think I covered pretty much everything on the web page. Yeah, if you guys are going to email me, please use this email. I have like 6 emails now because I just keep creating new ones. UNLV created a couple for me, and I don't want to be searching through like 6 inboxes for stuff because I might miss something. So for your own benefit, please use this email. It's the only one I have linked anywhere on this page. It's linked here. It's linked both places down here. So please, if you're going to email me, use that email. And let's open up LTspice so I can kind of show you guys what it looks like. So LTspice is this software right here. When it defaults, so this is something I want to cover. When you guys turn in your homework, I'm going to have you turn in LTspice plots. That'll be like a little bit later in the semester. You'll have to turn in plots, like waveforms. LTspice defaults to a black background, and that's not good for printing. So it's going to destroy, it's going to just rip the ink right out of your printer, and it looks horrible. So please, I'm going to show you guys right now, actually. This control panel right here gives you, just kidding. Let's find it. I think it's in View. Nope, Window, Tools, Color Preferences. So you can change all the color preferences for the software here. You see this waveform tab? See how it's black? We don't want that. It looks good, it's great for like doing work, but when you print, it's really, really bad, and the waveforms really don't show up. So it's better off to just slide all the sliders. Oh, sorry, that's the waveform. You drop down the item that you're actually selecting, and that would be the background. And then you slide them all. And then now you get white background plots. So that's how you want to submit your homework when you submit a homework. Definitely not the black background. Please don't do that. Don't waste ink. I have an example of a homework here. I'm going to just pray that this camera actually doesn't go out of focus here. Let's see. Okay, so this is what your homework should look like. This is what I was saying earlier. So you see how I've got the prop. So the first thing you're supposed to do, these are homework guidelines. So this is how you should, carry out every homework assignment that you complete in this class. The question should be up above whatever I wrote and whatever I asked you to do. The question should be up above the problem that you're about to solve. Then you get LTspice simulations. So this is what a circuit looks like in the Mac version of LTspice. Because when I took this class, I used my Mac. And so I have my circuit here, and then I have my results here. And what this is saying is, okay, so I ran this circuit, and these are the voltages and currents flowing in the circuit. Now below, I've got my circuit and my hand calculations like boxed, and you can see, I solved for VS, I got 9 volts. The simulation solved for VS, and it also got 9 volts. So there's my verification that I got the same thing that the software got, so I must be right. Very, very rarely is the software wrong, but it can happen if, some settings are off. So if something like that happens, make sure a couple times that it's not you, and then come to me and ask me, what the heck's going on with LTspice. So yeah, this is what your homework should look like. It should be LTspice, and then your hand calculations all on the same page. And that's kind of how I did it throughout the whole homework. And then when you turn in your homework, you're going to staple the whole packet together just like this. And then you're going to fold it and write your name on the outside. I cannot tell you how hard this was for students in CP100. I had students turning in, okay, another thing, printer paper. Please use blank white printer paper. It's very easy to get your hands on. It's all over our campus. And I had loads of kids turning stuff in on, loose leaf lined paper, You can't even print on that, so it doesn't matter. You're going to be using LTspice, so that should not be an issue. But you take the homework, the whole stack, you fold it, you staple it, and then you fold it, and then you turn it in like this. The purpose is so that people don't see your grade when I hand it back to you, and it's easier for me to carry in one hand. So it should say your name, the class, and the homework assignment number, and that's pretty much all you're going to need on there. What's that? Yeah, do not do two-sided. So I have nothing on the back side of this page. Please only use the front side of your papers because it keeps it neat, and I want everything to be neat. So that's that. I'll post the homework guidelines. I didn't put those on the webpage, but I have like a written document showing them. I just wanted to show an in-person example of what it looks like so that you could see it, because man, oh man, people have struggled. Let's see what else. So I covered LTspice. I covered the homework. It might be time to start lecturing, guys.
I have a question about the homework.
Yes.
So since we're going to be doing it partially in LTspice, like you were saying, and also partially in calculations, the homework is going to be a bit of a copy and paste kind of dealio. We'll go to your posted homework and then we'll copy the question and then we'll paste it in like some random like document. Okay.
Yeah, that works. Whatever you want to do, you could write it if you want. I mean, it's obviously probably better if you don't. There we go. Yes, sir.
Well, it says it's not an LC. I don't plan on doing
Okay, then don't worry about it. Thank you for checking that out for me. I'll put it up whenever it is announced. If somebody lets me know, I'll keep checking. But yeah. So yeah, for the homeworks, basically just are you guys familiar with the snipping tool on Windows? Yeah. So the snipping tool is great. When you go in LTspice and build something. I don't know. Just throw something in here. Something like that. That might be your homework. That's never going to be your homework, but something like this. You just go and snip it, take a little snip and just drop that in to your document, whatever Word or Google Doc you're using. Another thing LTspice defaults to is a gray background for the schematics. So if I go back to color preferences, see how it says schematic here? This any circuit diagram that I'm going to go over, I'm not going to call it a circuit diagram because it's called a schematic. So from this point forward, I'm going to call it a schematic. So this right here is a schematic. If I go to Tools, Color Preferences, Schematic, so this is telling you what window we're in. Right now we're in the schematic window where I'm building stuff. This was editing the waveform window. This is the schematic window. So when you start, the background defaults to this like weird gray. I think that's like, I don't know, 180. I want you to just get a feel for what it's going to look like when you first open it. Something like this. You don't want that either because when you're doing snips, that's going to waste ink too. So just go to Tools, Color Preferences, and make sure that that schematic background is all white. And then we'll have no problems with that. You can toggle the grid on and off somewhere. That might be in here. No, I think it's in Window View maybe. Yeah, Show Grid. Can you guys see the grid? Okay, yeah. So if you want a grid, you can turn that on and off. You can change the color of the grid too. I think if you go to Color Preferences, grid, yeah. So you can, I already have it as black, so it's as dark as it's going to get. But you can do whatever you want with that. So yeah, obviously there's no homework today, but definitely when you guys get out of here, go on your laptop, download LTspice, and you don't have to start poking around with it if you don't want, but I'm going to start probably lecturing on actual EE stuff now that we've covered pretty much everything. Does anybody have any questions about anything I've said so far?
Do you want our homework to be printed in color or does it not matter?
So at first it's not going to matter because when you run these really simple circuits in the beginning couple weeks, there won't be any waveforms. So there's not going to be anything, moving around. It's just going to be the voltage here is this, like exactly like I showed you guys on my homework.
Right.
You're going to get something that looks like this. an output that shows you, the voltages and the currents. That's all you're going to get. So if that's black and white, I couldn't care less. But when you get later in the class, so this is like homework 18 for me, there are waveforms, and I'm going to need to be able to differentiate between the two. So another thing you can do in LTspice when you plot things is you can split the panel, so it won't just be one plot with two waveforms on it. You can get two separate plots, so then I can see which waveform is which, right? You can plot the red one on the line above and the blue one on the line below, and since they're labeled, I'll know which one's which. So if you guys can't print in color, that's totally fine. Just make sure you know what, here, let me just show you guys how to split the plot pane real quick. You probably won't need this for a minute, but I'll do it anyways, just so you can see it and I can answer your question. Wow, that's really bad. All right, so let's say I want to plot. Don't worry about anything I'm doing right now. It's just doing it for the sake of example. So I'll label this node voltage 1 and this node voltage 2. Ready? And now I'm going to run a simulation. So I hit run. See, I get this window here. This is the plotting window. You can move these windows around however you like for whatever purposes you need. And so when I click on V1, that voltage gets plotted. You see it's green? If I click on V2, that voltage also gets plotted and it's blue. But if you print in black and white, I'm going to have no idea which one's which because they're both going to be gray. But if you go add plot pane, so I right clicked and I hit add plot pane, now I have two of them and I can drag this one up here. So now you got two windows. That one's labeled V2, this one's labeled V1. Again, looks absolutely horrible because you can't see the blue on the black. So go to color preferences, waveform, background, and make it white and leave it like that. Now I can actually kind of see what's going on. Another thing you can do is you can thicken these up. If you go to color preferences, okay, I don't think it's color preferences actually. I think it's plot settings maybe. No, that's actually like asking you which traces I have. Tools, maybe it's in the control panel. I know you can change the thickness of the pen. Waveform, is that on there? Yeah. All right, data trace width, make it like 3 maybe. There you go, a little bit better. That'll be better for printing. So yeah, so there you go. So what we do: tools, control panel, waveforms, and then the trace width. So yeah, you can make it as thick as you want. Whatever you want to do. Same thing over here. I made mine thicker. When you default in LTspice, again, this is all recorded. So like if this stuff, you're like, holy crap, he's going over so much stuff right now. Like just don't, you can watch it on 0.25 speed later and then it'll be fine. So I think it's drafting options and then yeah, pen thickness. So if I change it to 1, this is what it defaults to. And it's like super duper thin, you see? If I go back and change it back, control panel, drafting, pen thickness 4. That's what I keep mine on because it just looks a little bit better. So again, don't worry about anything I just did because you're not going to need it quite yet. You'll need it once the homework's due on Wednesday. I'm going to go over how to do some of that stuff, but as of now, since we're pretty much done covering everything housekeeping wise, I'm going to start actually talking about circuits. Does anybody have any other questions about anything else I've gone over? All right, sweet. Let's hope this stays in focus. All right, so I'm going to start by talking about basically the 3 main things that we're going to talk about here are voltage, which has units of volts. Current, which has units of amps. Okay, it's actually amperes is what it's called, but we call them amps. And resistance. And I'm going to talk today about the relationship between the three of these things. These are the three quantities we're going to be trying to find this semester. We're going to be trying to find what is the voltage at this point, what is the current flowing in this circuit. Very unlikely that you'll ever have to find resistance. I'm usually going to be giving you resistance and you're going to be finding the other two with this very simple algebraic equation. So voltage has units of volts. Let me just push it out of here. Voltage has units of volts, current has units of amperes, and resistance has units of ohms, which is like a little omega. So those are your three, quantities that are going to be discussed in this class. And now I'm going to talk a little bit about what each one is. So voltage, I'm sure you've heard of voltage before. Voltage is also called electrical potential. And basically what it is it's how much force the charges are being pushed with. Electrical charge is being pushed around by voltage, and voltage is kind of like force. You can think of it, Dr. Baker uses this analogy a lot, like water. Think of electrical charge as the water itself, and in order to move that, if you just have water sitting in a pipe and you blow on it, like it'll move through the pipe a little bit because you applied some pressure or some force to the water. That's what voltage does. It applies that pressure required to move the electrical charge. Okay? So if you have more voltage okay, you know what? I'm going to go to resistance now. What resistance it is the amount of resistance, literally, that device has to current flowing. So larger resistance means that device is resisting the current flow more. You can think of it as a pipe for the water. A big wide pipe will not resist the flow of water much, right? Because it's wide and it's wide open. If you condense that pipe, or you kink a hose, you're adding a huge resistance. The water can't get through the hose like that. That's how resistance works in electrical circuits. If you have a really large resistance, that means that device is resisting the flow of electrical charge. If you have a really low resistance, it's not very resistant to the flow of electrical charge. And so basically, current is just telling you how much charge is actually flowing. So current is literally, by definition, charge per time. So it's how much charge is flowing per unit of time. And so basically, if you have a fixed amount of voltage, a fixed amount of pressure pushing these charges, and you have a fixed amount of resistance resisting those charges, the current is telling you how, based on that amount of pressure that you're applying and that resistance, how much electrical charge is actually flowing per second or per whatever unit time you're using. So this is going to be much easier when I do an example. However, I want to talk to you about, we all know what batteries are, right? A battery is an example of a voltage source, okay? So take a 9-volt battery, for example. That's an example of a voltage source. When you when you plug in a 9-volt battery to whatever device you need to plug it into, that battery is applying 9 volts to the circuit. And so now that is some, electrical potential or some force used to push the charges through the circuit. So when that's literally you powering it, is you're applying this potential. And so what a voltage source looks like, I drew it in Spice. Did I close Spice? Yeah, I did. Whatever. What a voltage source looks like in schematic view is something like this. It's got 2 terminals and a plus and a minus. That's exactly how a battery looks, right? Your battery has 2 terminals, whether it's a AA, a AAA, a 9-volt, even your car battery has 2 terminals, a plus terminal and a minus terminal. And so if this is a 9-volt battery, what that means is that there is 9 volts potential between the plus and the minus terminal. Okay? So that means I'm going to call this, just a variable, voltage 2, and I'll call this voltage 1. The difference in voltage between the 2 points is 9 volts. That's what a 9-volt battery is. Okay? So, if I took V2 minus V1, I would get 9 volts. Now, electrical ground is used as a reference to set a reference specifically to 0 volts. Whenever you see ground, that little triangle, that means that there is 0 volts at that point, or anywhere along that wire, there's going to be 0 volts. So now, in this equation, since V1 is connected to ground, this goes to 0, right? So what we have then is if you have a battery, I'm going to move this up a little bit. If you have a battery where the minus terminal is connected to ground, right? We know this is 0 volts. Then whatever voltage that battery is rated for, that tells us the voltage up top, right? Up here at the plus terminal. So say this was a 3-volt battery and I know that the minus terminal is connected to ground. I know that I have 3 volts here. Okay? And so that's just a little bit on voltage sources. You're going to see plenty of those throughout this class. Now I want to talk a little bit about Ohm's law. So I said resistance was in units of ohms, right? Ohm's law is giving us the relationship of these 3 things. So voltage is V. These are variables, okay? So when I'm trying to find the voltage, I use V. When I'm trying to find the current, I use I. I'm not sure why that is. Someone may know. I don't know. But current is denoted as I. Yo, you know why it's not C is because C is the speed of light. So they didn't want to confuse the two. So you have V for voltage, I for current, and then R is for resistance. And the relationship of these 3 quantities is given by Ohm's law. You're going to see and use Ohm's law over and over and over throughout the next however many years you're doing engineering. And that equation is that V equals I times R. That's it. It's that simple. So what that means is that the voltage is equal to the current times the resistance. And that seems probably meaningless as of right now, but now I'm going to discuss resistors. So a resistor in schematic, I drew them a minute ago, so let's just come back over here for a sec. This is what a resistor looks like in schematic. This is what a voltage source looks like in schematic. So, you know, a voltage source has the plus and the minus terminal. And then the resistor is this little zigzaggy looking thing. So let's go back over here. So I'm going to draw a voltage source here, so you know. And then a resistor looks something like this. I want to also note that when I draw circuits, we usually draw them in this fashion, where you know you have the voltage source upright and you have the resistor vertical. That resistor can be vertical, horizontal, diagonal. It doesn't change anything about anything. I don't want you guys to get used to looking at circuits that look the same, because the way it looks doesn't really matter. What matters is the connections. So, you know, let's say I connect this voltage source to this resistor like this. If I take this whole entire circuit and I rotate it around, that is the exact same circuit, right? That is the exact same circuit. It's just rotated. It looks very different, but it's the same circuit. So I'm just saying this because I know a lot of times people will say like, yeah, the voltage on the top, the voltage on the bottom, like there's no top and there's no bottom. This is just a diagram, okay? So what I'm going to do in this class is I'm going to bring in wires, I'm going to bring in resistors, and I'm going to bring in a battery, and I'm going to actually build a circuit under the camera, and I'm going to test the voltages, and I'm going to show you guys the currents, because I think it's very important that you don't get stuck thinking about a voltage source as that. because that's just a symbol of a voltage source. A voltage source is a power supply. It's a battery. It's something that's actually supplying power. A resistor looks like that in schematic, but in real life it looks very different. So I'm going to bring that stuff in. I think I had it listed for the third lecture, but maybe I'll do it Monday. I just want to show you guys what these things actually look like so you can get a feel for what I mean when I say this is not the top of the circuit or the bottom of the circuit. This is the plus terminal, right? This whole node, anything connected here is the plus terminal. That's not the top or the bottom. Just for your own knowledge, there's no like physical circuit here. There's just a diagram of a circuit. So you'll see when I build them, that here, let's come back over here and just for the sake of example. So I said, right, I'm running out of space on this page. Let's come up here. I said, right, that this, if I connect the voltage source with the ground at the minus terminal, if this voltage was 3 volts, then that means this voltage is 3 volts. If I flip this, right, now I'm drawing exactly the same, but upside down. If I put ground right here, ground is, see, some people might be tempted to say like, oh, ground's up top now. It doesn't matter. Ground is still connected to the minus terminal. So this, if this was a 3-volt battery, this is still 3 volts, right? That's all I want to get across, is the fact that the orientation of the diagram doesn't matter. What matters is the connections. So you'll see why, as we get into further and further circuits, voltage sources will be tilted sideways, they'll be diagonal, they'll be all over the place. They have different symbols. Another symbol for a voltage source, something like this, like a big bar and a little bar, and where the big bar is the plus terminal and the little bar is the minus terminal. That's another, voltage source. You might see it look like this. Still got it on here? Yeah. Something like this. Again, where the big bar connected to this wire denotes that that's the plus, and the little bar down here denotes that that's the minus. So these are all different ways that you might see a voltage source. So that's why I'm not gonna use these notations, just because that's not how it looks in LTspice. So that's not going to be very beneficial to you. Yes.
I guess this is a little bit out of the scope of what we're talking about. Will we use AC voltage sources as well?
Yeah, we will. Very late in the semester, because this is a DC circuits class. EE221 is AC circuits. So, but I want to cover it a little bit so that when you go into 221, you have seen it before. Right. For those of you who haven't seen it before. As far as, AC and DC, so let me actually talk about that a little bit. That's pretty important. So you guys have heard of AC/DC, I'm sure. What AC stands for, you know what, I'm going to go into a new page. Sorry. So AC stands for, is it focused? Sweet. Alternating current. And what DC stands for is direct current. So these are the two different types of electrical, waveforms. A direct current waveform is a waveform where the current just flows straight on through. It's just charges are flowing. So if I have a circuit, I'm going to draw a little DC circuit here. Voltage source. Put one resistor. It's all depending on the source. So this voltage source is just a battery. We'll call it a 9-volt battery. I have my minus terminal connected to ground, which means this voltage here is 9 volts. And now I'm going to apply Ohm's law, which I said earlier, to this circuit. Let's say this is a 1 kilo ohm resistor. So another thing, just a real quick aside. Everybody knows kilo means 1,000, right? Mega means million. There should be some commas. So we probably won't get above mega ohms in this class, but you'll definitely see kilo ohms on pretty much everything. I'll have it as like 1K. So just know that the K means kilo. It's not a unit. It's 1,000. So that's a 1,000 ohm resistor.
That's what Spice does as well, correct?
Spice.
I noticed that when you were labeling them earlier, they were voltages.
Yeah, I mean, if I go into Spice and I take this resistor and I want to give it a value, I can write 1K and it knows now this is a 1,000 ohm resistor. However, I can also write 1,000 and it's the exact same thing. So get in the habit of using the prefixes like 1 kilo ohm. But know that if you don't, so for example, let's do a half of 1,000. Half a thousand is 500. So if I write 500, that's perfectly valid. And so is 0.5K, right? That's half of 1,000. So that works just the exact same in Spice. It'll recognize it exactly the same. So that's just telling me how much resistance there is. If this number is larger, it means that resistor resists electrical current more. It has more of a resistance to the charges flowing through it. Okay? So the larger that number is, basically, for a fixed amount of voltage, less current will flow. And that's what we'll see from Ohm's law. I'm going to go back over here and do that now. So like I said earlier, voltage is equal to current times resistance. Okay? So what this applies to is a resistor. This applies to a resistor. So if I have a resistor, you're good. If I have a resistor, what I have is a resistance, right? Over here I have 1 kilo ohm. Okay? I have a voltage potential across that resistor, right? In this case, I have 9 volts here, and since this node is connected to ground, I have 0 volts here, okay? So across this resistor, what I do is I take the voltage on one side minus the voltage on the other side, and that tells me that tells me the voltage across that resistor. So in this case, 9 volts minus 0 volts gives me 9 volts, right? So I have 9 volts across this resistor. I know that now is my V in this equation, okay? I know that there's 9 volts across the resistor, so V equals 9 volts, okay? I also know resistance is 1 kilo ohm, okay? So now I can plug those into the equation and find out how much current is flowing in the circuit, specifically through the resistor, but in this case, since it's just one loop, it's the same current flowing. I'll talk more about that later or eventually. But as of right now, just for now, we know V, we know R, we need to find I. That's what's going on here. That's what Ohm's law does. If you have voltage and resistance, you can find current. If you have voltage and current, you can find resistance. You know, any two of these variables, you can find the third. So if I wanted to solve this, I would say 9 volts is equal to I times 1 kilo ohm. And now I can divide, this is where the algebra comes in, I can divide both sides by 1 kilo ohm. These cancel, and now I get that my I is 9 volts divided by 1 kilo ohm, which is 9 milliamps. So, again, I said K was 1,000, M, big M, so this is a capital M. That's mega, but little m is milli, so definitely distinguish between the two of those. Milli means 1,000th. And then you have micro, which is 1/1,000,000th. This is also denoted by 10 to the minus 3, 10 to the minus 6. So in this case, I took 9 volts and I divided it by 1,000 ohms, right? So if I take that, do I have my calculator?
You're also a bit off camera.
Am I? Oh, down here. Whoops. Hang on. All right, so 9 volts divided by, so that's the same thing as saying 9 volts divided by 1K is equal to 9 volts divided by 1,000, which is, so if I put that on my calculator, I mean, I know what it is, but I just want to show you guys. Whoop. That gives me 0.009. Which means I have 9 milliamps. So here's something I wanted to show you guys. I don't know, how many of you guys have a TI-84? Okay. Most of you guys probably have some sort of scientific calculator. I want to show you guys this for those of you who don't know or have never seen this. If you go to mode, I think most calculators probably have something like this. You can change it to engineering mode. And what that does, wow, that's not what I meant to do. Did I even save it? Yeah, okay, so it's in engineering mode. So now if I do the same thing, right, 9 divided by 1,000 gives me 9 times 10 to the minus 3. So now if you know 10 to the minus 3 is milli, you already know that's 9 milliamps. Like you don't even have to think. So that's what engineering mode is good for. One downside of it is if you do just a normal number like 9, you'll keep seeing the times 10 to the 0 thing pop up every time. So if you can ignore that, that's good. I don't keep my calculator in engineering mode, but if you don't want to deal with trying to figure out units, I would definitely recommend it. Because like I said, right, milli is 10 to the minus 3. So if you see 9 times 10 to the minus third power, then you already know that the unit here is milli, whatever it is. It might be millivolts, it might be milliohms. In this case, it was milliamps because we were trying to find current, right? And I said earlier that the unit of current is amps. So just for if you guys want to use engineering mode on your calculator, that could be beneficial. You'll also see, I think in LTspice, if it's milliamps, I don't think it'll give you 9 milli. It'll say 0.009, right? So you'll have to kind of know, like, okay, 9 times. Everyone knows. Is anyone confused by this? Like negative exponents, or is that all pretty like trivial? It's good. So yeah, basically, in the case where you get 9 times 10 to the minus 3, am I still on the camera?
Yeah.
That is the same thing as saying 9 milli. And if I get 9 times 10 to the 3, that's the same thing as saying 9K. So just know that we're going to be using these. You use prefixes like these all the time in engineering. Definitely in this class, we're going to be using them a lot. So just, be prepared for that. Let me go ahead and do another example here. I want to talk about, so in this case, actually, let me just stay on the same example and draw it a little bit better over here. So if I have a resistor, and I have 9 volts here, and I have 0 volts here, my current is flowing this way, right? That's how current is flowing. It flows from the larger potential to the smaller potential, okay? So I think on the first homework, I asked you guys to let me know what direction the current is flowing by denoting it with an arrow. And so in the case where you have 9 volts here and 0 volts here, the current will be flowing this way. So in this circuit, I had 9 volts up here on the, connected to the plus terminal of the battery, and I have 0 volts connected to the minus terminal. So across this resistor, my current is flowing like this, right? It's flowing from the higher potential to the lower potential, okay? So, and then that follows around this loop. That's the direction of the current in the entire loop. So you'd have, your current will be flowing like this, this way through the circuit. If I were to flip it now, so let's over. I got room. Let's do it over here. What do we got? All right, there we go. If I flipped it, I wrote minus plus 9 volts, and I drew the ground up here. So now I'm drawing basically the exact same circuit, but now I have 0 volts here. But see, this is what I'm saying. This is the exact same circuit, but you just have to note where the connections are. So here I had my ground connected to my minus terminal. Here I have my ground connected to my minus terminal. So, and then this is a 9-volt battery, so I know I have 9 volts here. This is a 1K resistor. And so again, if I wanted to solve this, I know I have 9 volts here and 0 volts here, which means I have 9 volts across the battery. Right? So in this case, my V would be 9 volts. My R, again, I said 1K. So now if I wanted to find I, I is V over R. In this case, it's, again, 9 volts divided by 1K, which gave me 9 milliamps. But in this case, I have 9 volts here and 0 volts here, so now my current's flowing this way, right? It's flowing from the 9 volts to the 0 volts, okay? So in this circuit, if I were to draw like a loop, it would be flowing like this through the circuit. Does that make sense? Question.
So do we get the current from looking at the resistor or voltage source?
So you get the current, like the direction or the amount of current? The direction? So the direction of the current is dependent solely on what the voltages are on either side of the resistor, okay? So in this case, I had 9 volts here and I had 0 volts here, right? So my potential here is larger. The current wants to flow from the larger potential to the lower potential. So in this case, it's flowing this way, right? Over here, I had 9 volts here and 0 volts here. So in that case, it's flowing the other, it's actually flowing the same direction in a practical circuit, but because of the way I drew it, it's flowing down now because I have 9 volts here and 0 volts here. Does that make sense?
But then for voltage source, at the bottom left, wouldn't it be 9 volts? Wouldn't it be 9 volts going down up to 0 volts?
Yeah, okay, I see what you're saying. So yeah, it's depending on the resistor then, in that case. So Ohm's law applies to resistors. It doesn't apply to a voltage source. A voltage source in LTspice is ideal. It doesn't have any resistance, so Ohm's law doesn't apply to the voltage source. Okay, so yeah, I see what you're saying because you're saying now we have current flowing, this way through the battery where this is 0 and that's 9, so that's kind of counterintuitive. What we care about is the resistor. So here, let me get another piece of paper. And I'll do it another circuit real quick. We're almost out of time. So focus. So in this case, I've got, let's say 2K here and 10 volts, just to switch it up. So if you have one loop in your circuit, which is what we have here, this is a single loop circuit, all the current flowing through the circuit is the same, okay? So if I have 10 volts here and I have 0 volts here, I already know without even knowing anything about anything else, the current in this circuit is flowing like this. And so the rest of the circuit follows suit. That doesn't mean that the current is flowing down like this. It flows in a loop. So you would just complete this loop and you know that the current is flowing like this, right? That's because of this resistor and because of the polarity of the voltage source. But basically, it sounds to me like your question was, why is the current flowing the other way through the voltage source? Because I just said that it flows from plus to minus, right? Well, it flows from plus to minus through a resistor. So that's what you're basing it on. Okay? So let me do one more thing to kind of clear that up a little bit. So we're going to get into like 2-loop circuits like this, where you see, 2 things going on. There's 2 loops now. This is a 2-loop circuit. So in this case, I would have 10 volts here. Well, let's call it a 10-volt battery. And this is all 0 volts. So in circuits, let me switch markers. Any branch that's not connected, this is all wire. This would all be wire. All of this. This is wire, 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 until you run into a resistor or some other component. Any amount of wire that's connected together, that's not touching a component yet, that is considered a node, and the voltage on that entire node is the same, okay? So in this case, the ground node is connected to the minus terminal of the battery, it's connected to this terminal of this resistor, and it's connected to this terminal of this resistor. That means that the voltage all over this node is 0 volts everywhere. It doesn't change along a node. It only changes when it runs into another component because of Ohm's law. There may be current flowing through that component. And if there's current flowing through that component, now we have voltage difference across the resistor, and you get a different voltage. So basically, this entire, let me change colors again. This entire thing up here is another node. This is all another node up until you reach the resistors. So this entire wire, all of this is going to have the same voltage. Does The voltage is not going to change until it runs into another component. And that's called a voltage drop. When voltage changes across a resistor, that change is called the voltage drop. So in this case, I had 10 volts here and I had 0 volts here. The way that you would say that is that there was a 10 volt voltage drop across this resistor. That's the terminology. That's the correct terminology. Only because there's a ground. So let me. I want to spend the last. You have a question?
Yeah, if you don't shut it to ground, it's going to be pretty different.
Exactly. So I was just gonna say, let me spend the last few minutes brushing up what I have said or haven't said about ground. Ground is used as a reference so that we can, because like I said earlier, right? If I give you a battery and I tell you this is a 9-volt battery, all that tells me is that the plus terminal is 9 volts greater than the minus terminal. It basically tells us there's 9 volts across the battery. But if this voltage right here is not 0 volts, I have no idea what this voltage is. If this is 3 volts, this is 12 volts, right? Because there's 9 volts difference between the 2 points. That's what the voltage source is telling you. Okay? We use ground to make our lives easier because you need a reference. Otherwise, we're not going to know what any voltages are. So we use ground as a 0 volt reference so that from there, we know, okay, if I go from this 0 up 10 volts, I already know this is 10 volts. You don't have to think, right? If I didn't have ground here, like they're saying, right, we wouldn't know either of these voltages. All we know is that this voltage is 10 volts higher than this voltage. Does that make sense? Okay. So in general, I'm going to get into like flipping the battery and negative voltages next class. I don't want to keep you guys any longer. But real quick, if you see a battery and the minus terminal is connected to ground, whatever this voltage is, we'll call it Vx, that's telling me the rated voltage for this battery or that voltage source. This voltage will be that voltage, the voltage up on this node, because, right, I said the battery voltage rating is telling you the voltage difference between these 2 points. If this is 0, this has to be Vx. So if it's a 10 volt battery and it's connected to ground, the voltage up here is 10 volts. If it's a 2 volt battery and this is connected to ground, the voltage up here is 2 volts. That's going to hold true forever. Once the batteries flip and ground is connected to the plus terminal, you get negative voltage. I'm going to discuss that next time. I don't want to get into it yet. Like I said, your first homework's not due till next Wednesday. I actually think I'm also going to push the first quiz to next Wednesday, just because I don't know if I got as far as I wanted to yet today. So don't worry about anything. Enjoy your weekend, and thank you guys for coming. Oh, please turn in these papers. Just slide them all to the end of the table, and I'll collect all of them.